What if the first chapter had been written long before humans appeared? When scientists began asking that question seriously, they discovered a thought-provoking truth. Perhaps proving that an ancient civilization once existed is even harder than finding life on another planet. Earth is like a colossal machine, constantly rewriting itself. A place where every trace of the past is not preserved, but crushed, recycled, and dissolved back into the heart of the planet. For modern geologists, this is a living, dynamic system where Earth's crust is always in a state of destruction and rebirth. According to the United States Geological Survey, USGS, tectonic plates continuously move at a rate of a few centimeters per year. But over tens to hundreds of millions of years, that is enough for the entire ocean floor to be pulled down into subduction zones, melted into the mantle, and recreated as new crust along mid-ocean ridges. This cycle means that the oceanic crust almost has no memory, beyond roughly 100 to 200 million years. This leads to a cold truth. Any civilization, no matter how brilliant, if it existed far enough back in the past, would be almost completely erased by this system. And it is not only the oceans. Even the continents cannot stand firm against time. Mountains are worn down by wind and water millimeter by millimeter each year. Rivers carve through landscapes like invisible blades. And glaciers, across long climate cycles, can scrape entire continents flat over millions of years. Human-made structures, whether as solid as pyramids or modern concrete, are only a brief moment on the scale of geology. Imagine a simple but haunting scenario. If humanity disappeared today, what would happen next? Within hours, water pumping systems in low-lying cities like New York would stop working, and subway tunnels would begin to flood. Within a few years, vegetation would invade the streets. Tree roots would break through asphalt. After about 10,000 years, according to models presented in Alan Weisman's The World Without Us, most cities would be erased by nature to the point that they would be difficult to distinguish from the natural landscape. But that would only be the beginning. After 1 million years, what remained of industrial civilization would almost completely vanish from the surface of the planet. Steel would oxidize into iron oxide and break down. Concrete would weather into sediment. Glass would be shattered and scattered through the soil. Even landfills, things that seem almost indestructible, would either be buried deep beneath new layers of strata or transformed by microorganisms and groundwater. If a future archaeologist or another civilization searched for traces of us, they might find only tiny chemical anomalies in the rocks and soil, rather than any clear structures. And this is the truly shocking point. If an industrial civilization had existed before us, they would not only have faced their own extinction, but also a planet that would erase nearly every piece of evidence that they had ever existed. And if that is true, then among all the things this planet has wiped away, what could be durable enough to survive millions of years and reach us today? The answer lies in things so small they are almost invisible. The industrial fingerprints imprinted into the very chemistry of the planet. Modern geologists increasingly agree that the most durable trace of a civilization is not a structure, but a disruption in the natural system. Geologist Jan Zalasiewicz, who took part in research on the Silurian hypothesis, once raised a haunting question. Could a civilization be detected only through very small anomalies in sedimentary rock? And the unsettling part is that the answer may be yes, but not in the way we imagine. Among them, plastic is a particularly strange paradox. Something created for short-term use is becoming one of the most geologically durable materials. The frightening part is that all of these signals are being created right now, and they will be locked into sediment in the same way Earth has always operated, slowly but irreversibly. That is why the Silurian hypothesis of Adam Frank and Gavin Schmidt becomes so remarkable. An industrial civilization, if it once existed in the deep past, might leave behind only geochemical traces, not physical ruins. And this is the key point. The thing that survives the longest is not an object, but the change a civilization makes to the chemical structure of Earth itself. But if those traces had once existed in the past, then why have we still never found any clear evidence? And to answer that question, we are forced to go even deeper into one of the strangest periods in Earth's history. 56 million years ago, when the planet experienced a carbon shock frighteningly similar to the present. The PETM, the Paleocene-Eocene thermal maximum. According to data from NASA Earth Observatory and paleoclimate studies, in a brief moment on the geological timescale, global temperatures rose by about 5 to 8 degrees Celsius, enough to restructure the entire planetary ecosystem. The oceans became more acidic, carbonate-shelled marine organisms declined sharply, ancient coral reefs collapsed on a massive scale, and subtropical forests began spreading toward near-polar regions that had previously been cold. The frightening part is not the scale of the transformation, but its speed. When PETM is placed beside the present, a chilling resemblance begins to appear. Scientists at NASA and many international climate organizations have pointed out that the current human-driven rise in carbon is following a similar kind of curve, differing only in its source. This similarity raises a disturbing question. If we see an event that looks exactly like the Anthropocene in the distant past, but with no trace of technology, how would we explain it? In sediment cores, PETM left behind no cities, no machines, no plastic, and no refined metals. It left only carbon, temperature, and ecological change. If an industrial civilization had existed before that, every physical sign of it could have been erased by time, leaving only chemical distortions indistinguishable from natural processes. And this is the paradox the Silurian hypothesis later tries to confront. The boundary between a natural catastrophe and a trace of intelligence may become so blurred after tens of millions of years that it is impossible to separate. Some paleoclimate researchers have even called PETM a case without a culprit. And it is here that PETM is no longer merely an ancient climate event. It becomes a thought experiment. Is it possible to detect an ancient civilization only through disturbances in geology? And from this very point of suspicion, a bold hypothesis was born. One that would move the investigation away from the safe zone of traditional science and into the most dangerous gray area of deep time. The Silurian hypothesis. This hypothesis was proposed in 2018 by Adam Frank and Gavin Schmidt, NASA GIS, along with their colleagues, in a paper published in the International Journal of Astrobiology. The most important thing to emphasize from the very beginning is this. They did not claim that an ancient civilization existed. On the contrary, they deliberately maintained a neutral and even skeptical position. But they raised a fundamental problem. Are current scientific methods enough to detect a civilization that has completely disappeared from the surface of Earth? To understand how uncomfortable this question really is, look at the way we search for the past. Traditional archaeology depends on structures, tools, fossils, or architectural remains. But geologists like Jan Zalasiewicz, who studies the Anthropocene, emphasize that on a timescale of tens to hundreds of millions of years, those things are almost impossible to survive intact. This leads to a paradox. If a civilization existed 100 million years ago, it could have reached an industrial level, built cities, extracted energy, and changed the biosphere. But after tens of millions of years, everything belonging to them could have been ground down into background signal. No structures, no tools, no architecture, only very small geochemical anomalies left inside the rock. And this is the core point emphasized by the Silurian hypothesis. Perhaps the traces of a civilization do not disappear completely, but dissolve into Earth's background noise. For example, an ancient industrial society might leave behind an unusual shift in carbon isotopes, the appearance of unnatural refined metals, or changes in the rate of biological extinction. But the problem is that all of these signals can also be produced by extreme natural processes, such as large-scale volcanism, mantle disturbances, or methane release from the seafloor. That is why the Silurian hypothesis is a hypothesis about the limits of scientific perception. It sets up a situation almost like a crime scene. The scene has been wiped clean, the witnesses no longer exist, and the evidence, if there is any, has been mixed into the general geological background. In an article in The Atlantic, Adam Frank once emphasized that the issue is not whether we can find evidence, but whether we would recognize it if it were right in front of us. In that sense, the Silurian hypothesis is not only a hypothesis about Earth, but also a warning about how we read the history of the planet. We may be looking at the truth, but lack the tools to name it correctly. What makes us believe that only Homo sapiens could build a civilization on this Earth? In common perception, evolution is often told as a linear story. From simple microorganisms, complex animals, dinosaurs, mammals, and finally humans as the pinnacle. But modern evolutionary biology describes a completely different picture. Evolution has no goal, no destination called humanity. As evolutionary biologist Stephen Jay Gould once emphasized, if we were to rewind the tape of evolution, the outcome could be completely different, and humans would be only one possibility among countless possible scenarios. This means intelligence is not a miracle that appeared only once. In reality, it has appeared many times, in many different ways. We see dolphins with complex communication systems based on sound and individual recognition. Crows can solve multi-step problems and use tools to get food. And especially octopuses, mollusks that split from us more than 500 million years of evolution ago, yet possess a distributed nervous system and an astonishing ability to learn. According to Smithsonian Ocean, octopuses display a level of cognition that has forced many biologists to rethink the boundary between instinct and intelligence. If we look more broadly, we see a phenomenon that biology calls convergent evolution. Similar solutions appearing independently in different evolutionary branches. For example, complex eyes have evolved many times in different species. Flight also appeared in birds, insects, and bats without a direct relationship. This suggests that intelligence may not be a rare exception, but a repeating solution when the environment reaches certain conditions. Richard Dawkins once described evolution as a process that continually finds similar solutions to the same survival problem. And if intelligence can appear many times, then Earth has had enough time to test it millions of times across the 3.5 billion year history of life. We are only seeing the final surviving branch, Homo sapiens. Look at the dinosaurs. the creatures that dominated this planet for more than 160 million years. According to USGS paleontological studies on the KPG extinction event, over a period hundreds of times longer than human history, they evolved into countless, extremely diverse biological forms, from agile predators to species with relatively developed brain structures such as the theropod group. Paleontologist Dale Russell once proposed the hypothetical dinosauroid model, in which a small dinosaur like Troodon could have evolved into a highly intelligent being if history had not been interrupted by the Chicxulub asteroid. But it shows one important thing. Earth once had enough time and enough conditions to create many different forms of intelligence, not just one. Humanity's mistake lies in its own evolutionary intuition. We often equate civilization with what is familiar: cities, tools, technology, complex social systems. But modern archaeology and evolutionary anthropology show that civilization is not an absolute state, but a continuous spectrum of organizational ability, accumulated knowledge, and energy exploitation. Ian Hodder, in his studies of ancient settlements such as Çatalhöyük, emphasized that what makes humans different is not only intelligence, but the ability to accumulate social memory across many generations. And here, a key point begins to emerge. Earth's history is not a stable flow, but a sequence of reconstructions. At least 5 major mass extinction events have wiped out most of life, including the Permian and KPG events. According to NASA and USGS syntheses on planet-scale biological change, each time the ecosystem was reset, opening an opportunity for new forms of life to dominate. If they once existed, what truly erased them from the history of this planet? And to answer that, we are forced to step into the moments when Earth was no longer the foundation of stable life, but became a system of global biological restructuring. The harshest moment among those resets was the Permian-Triassic mass extinction about 252 million years ago, also known as the Great Dying. Geological evidence shows that massive volcanic activity in the Siberian traps released enormous amounts of carbon dioxide and methane, triggering an extreme greenhouse effect, ocean acidification, and the collapse of oxygen chains in seawater. As a result, about 96% of marine species and 70% of land organisms disappeared. Paleontologist Douglas Irwin described this as a time when life almost completely went out, leaving only small fragments of ecological refuge. If a civilization had existed before this moment, all of its surface traces, cities, structures, materials, would have been buried, crushed, and recycled through tens of millions of years of plate tectonics afterward, with no chance of surviving as clear evidence. But Earth does not erase only through volcanoes. It also has cosmic final blows. 66 million years ago, an asteroid about 10 kilometers wide slammed into the Chicxulub region on the Yucatan Peninsula, creating a chain reaction that collapsed the entire biosphere of the dinosaur age. What matters is not only the impact, but the way it was recorded. In the KPG boundary layer, scientists such as Walter Alvarez discovered an iridium anomaly, an element rare on Earth's surface, but common in meteorites. These events are even more dangerous because they have no clear beginning. No single end-of-the-world moment. Only the gradual decline of living conditions. For a hypothetical industrial civilization, this might be an even worse scenario than an asteroid. The system collapses without anyone being able to record when it began. All of these mechanisms lead to a cold geological truth. Earth continuously recycles its own crust. Plate tectonics pulls the seafloor down into the mantle, where rock is melted and reborn. Erosion breaks continents down grain by grain. Volcanoes create new surfaces. Given enough time, every artificial structure becomes sediment, then becomes rock, then disappears into the deep geological cycle. Geologist Marcia Bjornerud once said, "Earth does not forget. It simply keeps writing over its own memory." And this is the key paradox of the Silurian hypothesis. If a civilization once existed, they would not only have faced natural disasters, but also the planet's own trace-erasing machine, for millions of years afterward. There is no guarantee that their technological, biological, or chemical traces would remain intact enough to be recognized as artificial. They may have been diluted into small anomalies in carbon isotopes, or dissolved into the natural geological background noise we are used to calling climate variation. Are we looking for them through things that, by their very nature, could never survive long enough to be found? If that is true, then the entire history of the planet may be hiding far more than it reveals. It lies deep within the layers of geological memory, where Earth accidentally records every disturbance like a colossal ledger. One that is never written in the way humans expect. This hunt begins to become a complex interdisciplinary scientific system. Researchers must combine geochemistry, paleoclimatology, deep-sea drilling, and even artificial intelligence models to decode the data. Programs such as the International Ocean Discovery Program, IODP, are drilling into the ocean floor at depths of thousands of meters, bringing up sediment cores one by one. places that preserve chains of history stretching across tens to hundreds of millions of years. Each rock core is no longer merely material, but a timeline containing climate fluctuations, biological changes, and the subtle chemical signatures of ancient oceans. Parallel to the ocean is another archive, even more delicate. The ice cores of Antarctica and Greenland. These layers of ice are like natural audio recordings, preserving ancient air bubbles that reflect the composition of the atmosphere hundreds of thousands of years ago. NASA and climate research programs have shown that ice cores can reconstruct Earth's temperature and carbon dioxide history with astonishingly high precision. Scientist Lonnie Thompson once described them as a diary the planet writes with its own breath. Far beyond the frozen surface lies the world of deep-sea sediment, where time is compressed with brutal force. On the ocean floor, every millimeter of mud accumulates over thousands of years, recording events such as mass extinctions, carbon shifts, and microbial changes. The problem is this: when everything is compressed and mixed together, the boundary between natural and artificial becomes so blurred that it is almost impossible to distinguish through ordinary scientific intuition. What humans once ignored as noise may now become the most important clue. What sends a chill through the mind is the possibility that we are not truly starting from zero. Some researchers have proposed that geological anomalies such as PETM, carbon spike events, or metal-rich sediment layers may have already been recorded, but have always been explained as purely natural phenomena. Because we lack the frame of reference to understand them in another way. One easy example to imagine is modern archaeology with the Maya civilization. Before LiDAR technology appeared, many structures were hidden beneath the forest and were considered non-existent. But when laser scanning passed through the forest canopy, an entire network of enormous cities emerged. Are we standing in a place where the structures of an ancient civilization are hidden not by time, but by the way we read the signal? And that is when the Anthropocene is no longer a concept, but an experiment unfolding right before our eyes. We are already inside it, the Anthropocene. The age in which human activity becomes a geological force capable of changing the structure of the planet. The only living evidence of how an industrial civilization truly leaves behind its traces. What makes the Anthropocene special is not that humans exist, but that we are creating geological fingerprints that may last far beyond our own history. This is the first time in Earth's 4.5 billion year history that a living species has left behind a signal that could be recognized as a synchronized global geological layer. Geologist Jan Zalasiewicz of the Anthropocene Working Group once described that we are creating a material signature layer covering the entire planet. A kind of fossil of modern civilization itself. But the paradox begins to appear when we look at the Anthropocene not from the present, but from the distant future. Scientist Gavin Schmidt of NASA GIS once emphasized, "Geology does not tell stories in sequence, it only leaves behind traces of events." The most important thing about this experiment is that it cannot be recreated. This is not a model, but the only living experiment of an industrial civilization on a real planet. What we are doing today will become the only data the future may be able to read about a civilization that reached a global level of energy and technological integration. And it is here that the Silurian hypothesis returns with its full weight. If a civilization before humans once existed, they too would have had only one chance, just like us. To leave behind traces clear enough before Earth erased everything. Are we leaving behind traces or not? The answer is already clear in every layer of modern sediment. But if this is the only evidence of a civilization, then who will be capable enough to read it after us? In modern evolutionary science and geology, it is becoming increasingly clear that complexity does not disappear at random, but is always filtered through harsh survival thresholds. This is the foundation of the Great Filter concept, proposed by researcher Robin Hanson as a possible answer to the Fermi paradox. If the universe offers so many opportunities for life, why have we still not seen anyone else? The first layer comes from the development of civilization itself. When a species reaches the industrial stage, it does not merely change its environment. It also triggers feedback responses from the ecosystem. Climate change, resource depletion, biological imbalance, and population pressure. The warnings about planetary tipping points from Will Stephan and the Stockholm Resilience Center show that Earth has thresholds which, once crossed, can push the system into an entirely new state, one that cannot return to its old condition. But even if a civilization survives itself, the second layer of the filter is truly more frightening. Earth is not an archive of memory, but a continuously recycling system. This is a period of time long enough to erase almost every physical trace of any civilization, unless those traces are preserved under special conditions. Imagine a modern city like New York or Tokyo. In a few thousand years, it could become ruins. In a few 100,000 years, metal structures would corrode, concrete would break apart, and every recognizable sign would disappear. And in tens of millions of years, there would be no city left. Only faint differences in the composition of sedimentary rock. Geologist Marcia Bjornerud once emphasized that Earth does not preserve history the way humans imagine. It continually writes over its own memory. The Geological Society of London confirms that these are potential stratigraphic markers for the future. Life can explode, evolve, even reach intelligence. But its memory is not guaranteed to survive alongside time. And it is here that a conclusion begins to form. One that is both logical and deeply unsettling. Perhaps the problem is not whether civilizations appear or not, but whether any civilization can survive long enough to pass through these two layers of the filter and leave a clear trace in Earth's record. On a 4.5 billion-year-old planet, tectonic forces and erosion continuously recycle Earth's surface, turning even the greatest industrial achievements into fragile traces of chemical sediment. The Silurian hypothesis reminds us that the absence of evidence does not prove humanity is unique, but only reflects the power of geological time to erase memory. Exploring the past is, in truth, a way to confront the future. To understand that we may not be the first chapter, and certainly not the final chapter, in the chronicle Earth has written and erased countless times. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.